All right, today we're going to do a quick refresher on like terms and combining like terms, okay? Because when we solve equations, we're going to deal a lot with like terms, okay? So up here we have a mathematical expression, okay? The terms of that expression are the values separated by our plus and our minus sign. So like 5x would be a term, 7 would be a term, negative 3x is a term, negative 9 is a term, and 6y is a term. Okay, so all the different terms there. So we've got 1, 2, 3, 4, 5 terms in that expression. The like terms are the terms that have the same variables, so they have the same letters to the same exponent. So same letters to the same power. Okay, so for example, the 5x and the negative 3x are like terms. And then actually the 7 and the negative 9 are also like terms because they don't have any letter attached to them. So they're classified as like terms. Okay, and what we're going to work on today is combining like terms. So how do we take an expression like we have up here and simplify it by combining those terms that have the same letters? Okay, so that's what we're going to focus on here today. Before we get to that, let's just quickly refresh our memory on like terms. So for number 1, are those like terms 5x and 3y? The answer is no, because they're different letters. Okay, for number 2, 9a and negative 2a, yes, those are the same letters to the same exponent, so those are like terms. For number 3, 7x squared and 5x, these are not like terms. Even though they're the same letter, the fact that one of them is squared and the other one is not, okay, means that they are not like terms. So they don't have the same power. Okay, and then for number 4, negative 6w cubed and 4w cubed, they are both w to the third power, w to the third power. Those are like terms. All right, so let's talk about combining like terms. For number 5, if I've got like terms like 6x plus 7x, the way to combine them is just by adding up the coefficients here. So the number out front is called our coefficient. 6 plus 7 is 13. And then the x just stays as an x. Just like kind of keeps its last name there. Okay. For number 6, 8w minus 4w. Again, those are like terms because it's the same variable to the same power. This time we're going to do 8 minus 4, which is 4. And then the w is going to come down right next to it. The w is kind of like their last name. We're like putting these groups together. It doesn't change their last name. It stays the same. Okay, when we do this, we got to make sure we pay attention to our positives and negatives here. So for number 8, negative 8h plus h, which is the same as 1h there. So negative 8h plus 1h plus 14h. Okay, since they all have the same last name, they're the same letter to the same power. They are all like terms. We can combine them down into one. All right, let's see. Negative 8h plus 1h plus 14h. So like if I'm thinking over here, I've got two positives. So a positive, and a negative here. So let's add up the positives. 1h and 14h gives us a total of 15h. So we're doing negative 8h plus 15h. If we've got 8 negatives and we've got 15 positives, okay, which team is winning there, the positive or the negative? 15 is greater than 8, so the positive team is winning, so it's going to be a positive, and they are winning by 7 points, so it's 7h. Positive 7h is our final answer there. Okay, so notice, right, we're really just focused on the coefficients out front. Okay, for number 8, 7y plus 7 plus 2y. So first thing we got to do is identify which terms we can combine. So in this case, we can combine the 7y and the positive or plus 2y. So 7y plus 2y is 9y. Okay, and then there's nothing really to add to this positive or plus 7, so we're just going to bring it down and leave it as it is. So 9y plus 7. And there's nothing else we can do with that expression. We can't combine the 9y with the 7 because they're not like terms. One of them has a y, one of them doesn't. We just have to know when to stop. All right, continuing on. Number 9, negative 4x minus 6 plus 10x. So we can combine the negative 4x and the positive 10x. Notice when I'm circling these like terms, I'm including the sign in front of them. So negative 4 and positive 10 should give us a positive 6x. And again, with this negative 6, with that minus 6, which is like a negative 6, there's nothing else to add to it or combine it. So we just drop it down and leave it as is. And then we stop there. There's nothing else to do. All right, on number 10, we can combine a couple different things here. So we can combine our negative n with our negative 9n. So let's see, these guys are on the same team, right? They're both negatives. So that's a negative 1n and negative 9n. Negative 1 and negative 9 is a total of negative 10n. And then we can combine our positive 10 and our negative 3. So positive 10 and negative 3 gives us a positive or a plus 7. All right, number 11, we've got 6m minus 9m minus 1m. I'm going to put the 1 in there as a reminder. It's always something that you can put there to help you out. So let's see. Let's look at our signs here. We've got a positive and a negative and a negative. So let's combine our negatives here first. So negative 9 and negative 1, those guys are on the same team. So we're going to add their scores up to make it negative 10m. Okay, let's bring down our positive 6m. So we've got now 6 positives and we've got 10 negatives. So the negative team is winning by 4 points, so we get a negative 4m. All right, number 12, negative 4r plus 6 plus r minus 6. So the negative 4r can be combined with the positive 1r. So let's see, negative 4 and positive 1. Those guys are on different teams. The negative team is winning by 3, so negative 3r. And then we can combine the positive 6 with the negative 6. So positive 6 and negative 6 actually gives us 0. That's like a tie game, right? The positives and the negatives have the same amount. So if that's the case, if it's 0, it just disappears. It's gone. So final answer on this one is negative 3r. All right, number 13, 4.8y plus 3 minus 1.7y. We can combine our like terms here. So that's the 4.8y and the negative 1.7y. So 4.8 and negative 1.7, we're going to subtract there. Gives us 3.1y. And then the plus 3 just gets brought down on the end. And then that's all we can do. We can't combine the y with anything else, or the y term with anything else. Let's see, 4.5k plus 7.8 plus 6.1. Let's look at this 4.5k to start. Is there any like terms that combine with that? And the answer is no. There's really no like terms that combine with that. So let's just bring down our 4.5k. Okay, we can, however, combine the 7.8 and the 6.1. Okay, so those are both positive values, so let's just add them up. 7.8 plus 6.1 gives me 13.9, and since it's a positive, it becomes a plus sign in between, so plus 13.9. Number 15, we can combine the 7 3/4 F with the 2 1/4 F. So let's see, 1/4 and 3/4 is 4/4. So that gives us 9 4/4, which 4/4 is just equal to 1, right? So we can change that, bump that up to 10. So that's going to give us 10F. And I really should include this plus sign when I circle it. Okay, and then this minus 4, that negative 4 or minus 4 is just going to drop down. There's nothing else to do with it. All right, 16, last one here on the front page. 5 2/3 F minus 7 1/4 F plus 8 1/3. We can combine the negative 7 1/4 with the positive 8 1/3. So these guys are on different teams. We've got a negative and a positive there. The positive team is winning, so it's going to be a positive value there. To figure out how much they're winning by, we're going to have to subtract. So 8 1/3 minus 7 1/4. Now we're going to have to get some common denominators there. So what can we turn? What if we turn them both to twelfths? So let's multiply this first fraction by 4. So that's going to give us 4/12. So let's rewrite that as 8 4/12. Okay, and then the second fraction, let's multiply it by 3. So that's going to give us 3/12. So 4/12 minus 3/12 is 1/12. 8 minus 7 is 1. So 1 1/12. And we already said it's got to be positive because there's more positives. Okay, and then to finish this problem off, this 5 2/3 F is just going to stay 5 2/3 F. So there's our final answer. All right, let's look at a couple more examples on the back side. For number 17, 18, and 19, it says simplify the expressions by combining like terms, then evaluate the simplified expressions when x is 4.2, y is negative 2.4, and z is 8.5. So for number 17, we have z plus z plus z plus z plus z, which is a bunch of 1z's, right? 1z plus 1z plus 1z plus 1z plus 1z. Okay, so if we plugged in our z value right now, okay, we can add them up, okay, but it'd be a little bit of work. So instead of plugging in the z value now, we can simplify this to 1 plus 1 plus 1 plus 1 plus 1. That's 5z. Okay, so and now when we simplify that to 5z, it makes our life a little bit easier to plug it in. So we just need to do 5 times our value of z, which is 8.5. So let's see, 5 times 8.5 should give us a final answer of 42.5. Okay, for number 18, 5x plus 3x plus y. So again, before we start plugging numbers in to make our lives a little bit easier, let's simplify what we can. So we can combine the 5x and the 3x to make it 8x. So let's rewrite that as 8x plus y. So now when we plug it in, we save a little bit of time. So that's 8 times 4.2 plus our y, which is negative 2.4. So this is a PEMDAS problem now. 8 times 4.2 is 33.6. And we have 33.6 plus negative 2.4. Those guys are on opposite teams, so we're going to subtract. 33.6 minus 2.4 gives us 31.2. And since we have more positive, our answer needs to be positive. All right, let's see. 19, 2y plus z plus 8y minus z. We can combine the 2y and the positive 8y to give us 10y. Okay, then we have 1z and negative 1z, which is actually 0z, so those actually disappear. So this expression simplifies to 10y. Okay, so all we have to do is 10 times negative 2.4, and 10 times negative 2.4 should give us a negative 24. Okay, so by looking to simplify those expressions, we can make our math work a little bit easier on us. All right, last two. Number 20, write and simplify an expression which represents the perimeter of the rectangle below. Use the simplified expression to find your perimeter when x is 3.9 and y is 6.2. Okay, so if I want to find the distance around the outside of the shape, which is our perimeter, I'm just adding up all of the sides. So I'm going to add up 2y plus 2y plus x plus 2 plus x plus 2. Okay, which is kind of a messy expression there, but if we combine our like terms, okay, we can simplify it a little bit. So for example, 2y and 2y is 4y. We can combine this 1x with this 1x to make it 2x. And then the 2 plus the 2 gives us a plus 4. So 4y plus 2x plus 4, which looks a little bit neater. Okay, so now let's take that expression and plug our values in. So we're going to plug in 6.2 for y. We're going to plug in 3.9 for x. And then we have that plus 4 at the end. All right, so let's see. 4 times 6.2 is 24.8. 2 times 3.9 gives us 7.8. Okay, and then we're just going to add all those up. So 24.8 plus 7.8 plus 4 gives us a total perimeter of 36.6. And it doesn't tell us if it's feet, inches, meters, centimeters, so we'll just say units there. All right, for number 21, write and simplify an expression that represents the perimeter of the hexagon below. So again, we're trying to find the distance around the outside of the figure here. So we're just adding up all the sides. So 1, 2, 3, 4, 5, 6 sides since it's a hexagon. Let's see, 1, 2, 3, 4, 5, 6, 7. Well, that's actually 7 sides, isn't it? That's a heptagon. That's my mistake there. So we have 7 sides we have to add up. All right, so again, we could at this point plug 5 3/7 in for A and just add up 5 3/7 plus 5 3/7, but that's going to take a while. So instead, let's take this big long expression, A plus 8, 7 times, and rewrite it as 7 times A. So now when we plug our numbers in down here, it's going to make the work a little bit easier. So 7 times A is going to be 7 times 5 3/7. So let's see, when we multiply mixed numbers, we want to turn them to improper fractions. So that's 7 over 1 times, let's see, 5 3/7. 5 times 3 is 35, plus 8 is 38, so that's 38/7. We can do a little bit of cross canceling. We can divide the 7s by 7, turn them into 1s. And then when we multiply, we should get 38 over 1, which is same as 38. So 38 units is our distance around the outside. All right, so there we have a little quick mini lesson on combining like terms and the value or how it can help us simplify expressions.